Welcome everybody. Regardless if you're an airframe, engine, landing gear, component or avionics maintenance shop, the overhaul process will follow these 9 basic steps. Here at Impresa, at each step we have witnessed examples of where the incumbent MRO ERP application and its existing processes have hindered rather than helped. Whether it's because of lack of functionality or excessive computer touch time, not enough focus has been made to improve the frontline co-face actions, with the result that valuable time is consumed with non-valuable added activities. Let's look back at a little history to learn where this began to change. 25 years ago, an analysis of the cumulative booked hours applied to a GE CF6-6 and -50 engine overhauls were plotted and displayed on a scatter graph. It showed that on average it took a shop approximately 33 to 37 days to accumulate 1,000 hours of billable labour. The next 15 days on average took another 2,000 hours were booked, with the remaining 200 or 700 hours booked over the last 13 to 20 days, giving an average engine overhaul turn time of 60 to 70 days. When we overlay the maintenance activities carried out over the same 70-day period, the lazy S-curve begins to make sense. One engine is disassembled to 30 plus modules, accessories, and quick engine change assemblies in the first 25 days, which in turn becomes thousands of parts being processed in the middle 25 to 45 days associated with the repair and replacement. In the last 15 days, the engine is assembled, tested, and finally shipped back to the customer. Throwing additional labour at the problem and having unlimited inventories will reduce the engine overhaul turn time, but our profit margins will suffer. Can key improvements be made across the whole overhaul process to effectively halve the turn time on a consistent basis for all engine types without compromising on quality? The company that carried out this analysis felt that our turnaround time target of 35 days for each engine type going through the shop was possible. The first area that came under scrutiny was the receiving to inspection process. Why did it take so long to determine the complete work content of an engine overhaul and the final list of replacement parts needed to make an engine fully serviceable? If it would be possible to reduce this initial phase to 20 days, then this would be a significant contribution to the overall target. With a customer's agreement, a single CF6-50 engine underwent a pilot study named Project 35, where everything about its overhaul process was put under the microscope, from work scope definition before receipt at the plant to getting the engine shipped back to the customer. At the end of the pilot study, the engine was shipped back to the customer 28 days wing to wing. The MRO company accomplished this by focusing on the 4 main pillars we see here: methods, manpower, machines, and materials. And while a lot of changes had an impact on the overall target, the biggest changes were made by 2 methods. The first was to implement a new MRO ERP system, and the second was to reorganize the complete shop floor. Using problem-solving techniques, grit and determination, the incremental improvements were deployed over time, and at the end of the project, a consistent 35 to 45-day engine turn time was established. The legacy system was replaced, and the systemic improvements garnered from Project 35 became and is Impresa's core capabilities shown here. Today, the application has been upgraded to a modern UI front end and open API architecture to ensure that if you have another system that you wish to keep active, Impresa can easily integrate to it. We continue to listen to our customers and learn from their experiences. Returning to our standard maintenance process flow, Impresa has made measurable improvements to each of these 9 process steps. For today's webinar, I want to demonstrate 2 key recent upgrades associated with the component and assembly overhauls. The first improvement is step 1, highlighted in red, receiving induction. In this use case, a component or assembly is received in the receiving bay with the customer's documentation. After verifying the component identity markings, the receiving technician can enter the details into the system without contacting and adding to the workload of the customer services department. We open the induction screen and select the customer. We select the part number and link that to the customer's contract. We enter the serial number and test for previous maintenance history. We continue to select the customer's work scope and also select the customer's ship to target address. We enter the PO and the PO line number and move to the additional information tab. Here we check the certification or warranty boxes, enter the priority, and if we know, we enter the ATA section code of the last airline operator, and then we enter the customer's instructions. We enter the reason for removal. We record the location where the shipping box will be put in the receiving area. We select any additional release requirements, Chinese or Indian. We enter any other general comments associated with the overhaul and customer's instructions. And then we finally enter the life limits, times and cycles, if we have them. The last step is to press the confirm button. The system prints the work order traveler with all of the information input during the induction and a traveler ID tag that goes along with the unit. This touchscreen functionality provides the capability to generate work in process data sets in under 3 minutes if all of the customer's paperwork is accurate and available. Not only does the receiving induction screen produce the shop floor paperwork, but the system generates a whole host of downstream data points that normally would require additional computing effort. The receiving induction upgrade was deployed at a high volume wheels and brake shop. After going live with Impresa, the shop compared their prior legacy system computer touch time and reported that one technician was doing the computer work of 2 employees. With functionality like this, Impresa can guarantee a 1 to 2 day reduction in turnaround time. Through working with our customers, we identify and work on solutions to help resolve their pain points. Impresa can do the same for your organization. Our second improvement is step 2, highlighted in blue. Work in process parts locator staging. During another of our customers' rapid improvement events, we watched their shop control personnel wander around the shop, wasting time locating jobs based upon the work order work cell. Space was premium, and the next work order work cell didn't always equate to the physical component location. Impresa has created work in process warehouses to represent the true physical shop staging areas. Shop controllers now use notepads, PDAs, or their phone, along with barcoded staging warehouses and bin locations to move product around their shop. Product locations are in direct control of the shop control personnel and not the repair planner engineer's work conventions. When a newly received assembly has got its work order travel documents and its ID tag, the part is moved into the shop by the shop control personnel. They see the first work cell location and from the traveler and move the assembly to the work cell staging area point associated with that first work cell. The user opens the WIP locator screen on their PDA. They want the barcode, then want the barcode of the staging warehouse and bin locations, and then they press the in button. At any time, a user can enter a work order into the system and immediately determine the job location. One additional feature is that the system keeps an audit log of all movements while in the WIP locator tracking, so we know who did what, where, and when. Now suppose in a classic use case is where you have the QA and engineering personnel withdraw a customer's unit from the shop to an office location. In Impresa, all the remaining open operations can be placed on hold, stopping technicians from booking labour against it. The user enters the work order and selects the engine hold, warehouse and bin location, and then presses the move button. And if we look at the work order operations, we see that the status of open operations has been changed to hold. Once engineering and QA are finished with the work order, they can move it back onto the shop to the next staging area using the same warehouse and bin barcodes and pressing the move button. If we look at the operations again, we see that the statuses now are open, allowing labour bookings to restart. Once all the work has been completed and the assembly is shipped, the user moves to the work order out of the WIP system. As mentioned earlier, all WIP movements are saved in history and an audit trail, so we know who moved what to where and when. This functionality has proven to increase shop controls productivity by 30%, giving them an easy and efficient way to electronically locate and track product movements. Regardless if a customer's unit is in for work, or an internal rotable, or a product is undergoing rework, the users have real-time information at their fingertips. Associated with this upgrade, Impresa is working on a graphical display of the product movements, staging area bottlenecks, and accurate queue time analysis. I mentioned that we've made improvements to the 9 basic maintenance steps. We do this by specifically focusing on high-frequency tasks. Examples such as labour booking and management, purchase order receiving, supply chain planning, tooling processes, and customer service quote-to-order management have all benefited from our execution excellence upgrades. At one of our customers' rapid improvement events, Impresa was requested to analyse the tooling checkout frequency. We provided a Pareto diagram of the extracted data, and in the end it showed that the safety harnesses and ladders were the highest frequency tools checked out, and these were located way back in the tool room. In total, over a 3-month period, over 19,000 tools were checked out and back in. At an average wait time of 18 minutes per tool, that accounts for a conservative 5,500 hours every quarter. The action they took was to revamp the tool room around tool checkout frequency. High volume tooling placed closest to the checkout window. The customer reduced the average tool wait time by 50%, recovering an estimated 10,000 hours annually. In addition to this huge opportunity for improvement, Impresa introduced functionality to identify and produce tooling calibration certificates for internally and externally calibrated tools over any desired future day range. The title of this webinar is Productivity Matters. Impresa Aerospace MRO software drives business performance at the shop floor level. Since the baseline functionality that the Project 35 obtained, we have continued to add and fine-tune the functionality. These gains required human insight and the ability to turn that insight into action through intelligent coding and physical process change when generative AI was nowhere in sight. As well as our own development ideas, we continue taking inputs from our customers. Today, generative AI is becoming part of our lives, At Impresa, we are currently looking at AI-assisted techniques that complement assembly and component line inspections. We should have something to show in a future webinar. In closing, Impresa prides itself upon providing functionality that supports enterprise maintenance operations. We are lowering the cost of ownership using accelerated implementation programs and aggressive pricing and payment plans, and provide customers with practical solutions connecting legacy systems where required. Should anyone want to explore Impresa functionality, we offer the above. Thank you for watching. I hope this short presentation has made you think a little about your current maintenance system and whether your company can afford not to take advantage of Impresa capabilities.